Hey guys, welcome back to the channel and this new tutorial on Pytorch. In previous videos, we learned how we can create a single layer neural network. In this video, we will see how we can create a deeper network and what are the issues when we don't use containers. Okay, so PyTorch containers provide us very efficient and simple way of creating deep neural network. Also, we have containers that makes it easier to handle random layers to update our train and so on. So in this video, we will mainly look at sequential layers, which are very useful containers for homogeneous layer organization. Okay, so we will see with an example here you can see we have a single layer neural network, and if I want to add another layer, I need to just copy these two lines of code again and again. Okay, so for example, I can say here it is nn2 and this is sigma 2. Now this would be we need to change two things here as well, so we need to say this. Let us say we are using hidden layer size input size only. So now it is two layer neural network, and when we need to call it, we need to call this again and again. Okay, so we need to call it nn2 and sigma 2 and so on. Okay, so now you see if you have a 20 if you have a 20 layer deep neural network, you need to copy these two lines 20 times. That is quite cumbersome, and that's why we have this sequential container that makes our life really easier. Okay, so let us see how we can create 10 layer neural network just using sequential um, container. Okay, so let us see. So now let us say we have output size, and let us now say num hidden layer. Okay, let us say we want to create a 10 layers neural network. Okay, and now let us also define what we want the size of the each layer, how many units we want. Okay, so let us say hidden layer size is equal to 128. Okay, now what we will do is we will simply create a loop. Okay, so let us run a loop for I in range num hidden layers. Okay, this will give us how many layers we want to create, and also let us create self dot modules. Okay, and let us call it nn.Sequential. This is how we want to create it, and now we will simply add modules to the sequential container. Okay, you can simply call add module, and we can simply name it. Let us call it ff. Now let us append the number, okay, so that it will be distinct, and we simply say nn dot linear, and we simply say input size and hidden layer size. Okay, for the first module or the first layer, the input size would be what the input we are expecting it to send, but further on it should be the hidden layer size cross hidden layer size. Okay, then only the network will work. I mean, we could have layer wise size, but I won't want to go in that much depth. If you want, you can just pass 10 numbers instead of just one number, and just traverse with that I and use that. But that's quite simple. Just we want to make it a bit simple, so we won't go in that uh, direction. Okay, and then we simply, for the next layer onwards, what we will simply do is input size is equal to hidden layer size. Okay, so for the first layer it should be input size cross hidden layer, and then later on it should be um, hidden layer size cross hidden layer size. Okay, And then at the end, we need to add one more module that will be hidden layer size cross output size. Okay. So we simply copy it and we paste it here, and we simply say, we can say classifier layer. Okay. And then we need to say hidden layer cross output size. Okay. And if you want to add another layer after that linear layer, like it is generally used, the non-linear activation, we can do that as well. Self dot module dot add module, and let us call it activation, and we simply say nn.Sequential, or let us use ReLU, that is more much better. Okay, so that it will be quite comprehensive. Okay, so that's our modules, and that's done. We have a network of 10 layers. Okay, and now in earlier case we need to call, like, for each layer we need to call it again and again and again. But when we create a model with a sequential layer or sequential container, we simply call it once. So what happens is, like, from the first module, it will simply keep passing the output to further layers, so that you don't need to call it again and again. So see, this makes the life really easier in that sense. Like, you don't need to write a lot of code. Okay. So now if you want to run the forward pass, you simply call tensor is equal to self dot modules, and then you simply pass inputs, and that's it. That's your neural network with 10 layers, and if you run it through, you will get the output of um 4 cross 16. Okay, sorry, 4 cross 2. Okay, so let us run and see it. Okay, my mistake. So self dot modules is a internal variable within Pytorch, so we cannot use that. So we will simply rename it to deep nn. Okay, so that it won't complain like that. So let us rename it to deep nn, and let us run it again. Now it should be fine. So you see, we got 4 cross 2 tensor. Okay. So now you see, like, how containers can be really helpful in certain cases. Like in this case, we used nn.Sequential to create a deep neural network. Okay. In the next video, we will talk about module list and module dict and see, like, where they are useful. And further on, also we will learn about parameter list and parameter dict. Okay. So thanks for watching. Bye for now. Take care. See you in the next.